In this video, we continue our exploration of forces by looking at the normal force. If you remember, the normal force is the force that a surface exerts on an object whenever that object is touching the surface. In other words, it's the pushback that a surface gives to any object that is touching it. And it is always in the direction perpendicular to the surface. Here in this example, we see that when an object is just lying on a surface, the normal force will be exactly equal to the weight of the object. But the normal force is an adjustable force. It can go from 0 up to and beyond the weight of an object, as we will see in the next two examples. Here we have an object with a weight of 10 newtons, and we would expect the normal force to also be 10 newtons. But what if a butterfly just starts flying around and lands on the block, and the butterfly has a weight of 4 newtons? Because now there's a total of 14 newtons pushing down on the surface will push back with a normal force of 14 newtons. The normal force can adjust with upward forces, just like it did with the downward force from the butterfly. For example, let's imagine two elephants approach the block and exert an upward force on the block. Now, because there's a total of 6 newtons of force acting upwards, the normal force does not have to be as strong to balance the 10 newtons of weight that was acting downwards. In this example, we have a tension pulling at 30 degrees. Now, this tension can be resolved into a horizontal and vertical component. Here we have the horizontal component, which will obviously accelerate the object, but we are only concerned with the vertical component right now, so we're only going to focus on the component in the y direction, which is t sine of theta. Now I'm going to redraw this vector and move it over to the top of the object, and we can use our values for the tension of 12 newtons and the angle of 30 degrees to calculate the tension in the y direction as 6 newtons. Because now we have a 6 newton force applied upwards, which was part of the tension, that counteracts the 10 newtons of weight going down, and the normal force is thus 4 newtons. In this final example, an object is on a 30-degree ramp, and weight points straight downwards. So we can look at the components of weight as being mg sine of theta in the x direction. Remember, it's a tilted axis. And we're familiar with that component of weight, that vector arrow, being moved up here to show that this is acceleration down the ramp. While this acceleration is important for motion of the block, we are not going to be too concerned with it right now. Instead, we're going to focus on the vertical component of the weight, which is negative mg cosine theta, negative because it's downward, and therefore the normal force will balance that by being positive mg cosine theta, directed straight perpendicular from the surface of the ramp. So in review, we see that the normal force is equal to the positive weight of an object on a level surface, and it's equal to the positive weight times the cosine of the angle on an inclined surface. And it's always important to remember that the normal force adjusts itself if other forces are pushing up or pulling down.